Dear students, welcome and thank you for tuning in. We are still talking about phase diagrams, part of the material science class. We have talked about binary phase diagrams in the previous video, and I hope that you have an idea about what is the phase diagram and how would it look like if we have two elements, copper and nickel, and the two phases and the three regions in this phase diagram. Just a reminder, it's called binary phase diagram because we have two components, copper and nickel, and it's isomorphous because it's complete solubility of one component and the other, and the alpha phase, which is the solid phase, field extend from 0 to 100% nickel. So you can start with 0 nickel, 100% copper, and you will end up with 100% nickel and 0 copper, and you have the phase center the cube solid solution spans the entire phase, and that's why we call it isomorphous. In this video, I want to show you how we can determine what phases are present using the phase diagram. Rule 1, if we know the temperature and the concentrations, then we know which phase is or which phases are present in our solution or mixture or material. Let's start with example 1. So let's say at point A, I am at 1100 degrees Celsius and I have 60% nickel and 40% copper. If we draw the lines from the temperature and the concentration, it's residing in the blue region, which is the solid solution region, the phase center cube, and it's an alpha phase. So from the diagram, I can see under these circumstances, which is the temperature of 1100 degrees Celsius and the concentration of 60% nickel and 40% copper, I know that I have one phase in my solution or my material. So if you are creating this material or you're manufacturing this material, you can know under these circumstances that if you mix copper and nickel with these percentages under this temperature, you will have only one phase, which is a solid state of copper and nickel. I was able to identify that because of phase diagram. If we have a point B, which is at 1250 degrees Celsius, and I have 35% nickel and 65% copper, if you draw the lines, you know that you are residing in this white area, which means that my solution or my material now has two phases, liquid and solid phase. It's now a mixture, it's not a solution. And this is how we are using the phase diagrams in identifying which phases are present depending on the temperature and the concentrations. Keep in mind that we are assuming the pressure is the same. So this is one of the applications for the phase diagram, and it's a good application, and we're going to show you more and more applications about how can we use the phase diagram in our analysis and understanding how to create material. So if you want to create a material that is solid, an alloy that is solid from these two elements, you look at, if you have a 60% nickel and 40% copper, you better be below the 1100. So you better be in that region, depending on what temperatures and pressure and concentration you're using. I hope that was helpful, and till next time.